So my name is Hovsepian. I am the SpaceShop manager. I started here last September, graduated from MIT, Department of Architecture and the Media Lab. My advisor was Neil Gershenfeld, if that name rings a bell at all. He started this whole Fab Lab network. So there are hundreds of Fab Labs all over the world, tech shops, all the DIY, do-it-yourself shops. So it was his vision at MIT to bring one of every machine in one space, and that came true. And that place is called the Mars Lab at the Media Lab. So what we're doing here today, and we opened up SpaceShop about 6 months ago. Not officially. We officially opened it up about a month ago. We have 150 users. We have the same tools, the same suite of machines that all other Fab Labs have, but we're hoping to create this in a way that it sort of grows around space applications. So it'll be the first Fab Lab for space, first NASA that has a Fab Lab. And what I've created here, you guys can pass this around and take one, is one workflow. You can imagine there are infinite workflows. There are 8 different machines that we offer training classes for and allow students to use. You can imagine if you combine these 8 machines in infinite ways, what could you make? So here's one workflow to make a small sat or a CubeSat. And the story is a comic, and it goes one by one how you can use one of each machine in there to make a part of this CubeSat. So you can grab this, put on your safety glasses, please. So we are in the additive subtractor group. This is one machine that we teach a class for. All the machines, notice as we walk through, there are training manuals. We spent the last 6 months here developing the most comprehensive safety-specific training manuals for any of these machines, and we're hoping that every Fab Lab out there, anyone using a laser cutter, will consult our documentation, because we spent so much time and energy into developing these super specific training manuals. Anybody training on this machine, so first of all, what does this machine do? It cuts and it etches any material, except it cannot cut metal, so we don't have that laser. But we can etch metal. So this is an anodized aluminum piece. For your training on the laser, you make your own SpaceShop badge. So that's what users and students end up making. It's about an hour-and-a-half class, and so that's what we do with that. In the context of your story, I'm not going in order, but you would use the laser cutter to mark parts or components of that CubeSat. So imagine you're creating a Lego kit of parts for a CubeSat. You're going to send that out to space, and an astronaut's going to have to put it together. So you're going to label the parts so the astronaut knows what fits into what, etc. And actually, we do have all the machinists downstairs come up here from time to time, and they use our laser cutter to name, various parts of a nose cone, for example, that's going to go in a wind tunnel. So the laser cutter comes in use very often. Another machine that we have here is a Bits from Bytes printer. This is a 3D printer. Essentially, it prints 3 materials at the same time. It has 3 deposition heads, and it has about a foot by foot by foot build volume. You can use PLA or ABS, so you can print 3 materials at the same time. PLA is a shiny material. ABS is more of a matte material. And what do you do with the two? So, say you have an intricate part that you want to print and you have PLA. You can use PLA as support structure. PLA is starch-based. So if you build your final part with PLA support structure, you can take the two, put it in a tank of sodium hydroxide, and it dissolves away the PLA, and now you have your strong ABS part. So really you can use PLA for intricate structures when you're 3D printing in layers. The other 3D printer we have behind you, that is the up printer. The up printer uses 1.75 millimeter filament. In the context of your story or your comic, we end up printing the structure of the CubeSat. So all of these pieces actually come together like so. So these are just 2 components, but this is the rail for a CubeSat, and this is a panel for a CubeSat. You can put both of these together and create one side panel for a CubeSat, and you'd have LEDs in there, all the electronics would be inside. This specific machine prints, so the resolution of that is about 0.15 millimeters a layer. The bed heats up, the nozzle heats up, and it simultaneously, the platform goes up and down, and it allows you to print, again, in layers. So that's the up machine. This typical printer, there's a typical 3D desktop printer costs between 2 and 6K. This is about 2K. and it's probably one of the best desktop printers that we've found so far, just from all the testing we've been doing. So if you guys are interested in getting your own, get the Up desktop printer. Okay, so we've also created a lot of we're going to be putting up our safety signs that we made on the printer. So we're hoping to use all the machines to make a lot of our own applications and needs, whether it be facility, tables, stools, chairs, to actual space parts. So moving on into this room, it has a mill, there's a cutting bit, and you can use a 1/2 inch diameter cutting bit or down to a 32nd of an inch cutting bit, so anywhere between. But what it does is you put this end mill at the end of this and it spins really fast, up to 25K RPM. And you can cut anything from wood to plastic so these are polyethylene milk carton material. We had several cylinders of these laying downstairs and we're going to throw them away. And we said, wait, we're going to use that for our training. So we cut them up into 1 inch thick pieces. And so everyone that trains on this specific machine ends up making their own NASA logo. It's a 3-hour class. So an hour and a half we spend training them on the software, then another hour and a half on actual how to set up your material and print. So again, this is another ShopBot training manual. These are all online, by the way. If you guys want to see all this, it's on spaceshop.arc.nasa.gov. It's also outside on the board. Also, we made, this is another model we made on the ShopBot. This is the Copernicus crater on the lunar surface. We ended up milling this a couple months ago. It took about 3 hours to mill. This is polystyrene. So we did a roughing pass and then a finishing pass, and finally we took a heat gun and we applied it about 2 feet away all over the board, and we got it pretty smooth, you can see. So that's another example of what you can do. That's an STL file. So you can get any 3D or 2D file and upload it to the ShopBot and cut out whatever you want. It's really cool.
What crater was that, did you say?
It's the Copernicus crater on the lunar surface. Yeah. There's a giant file out there. We had to downsize it and just pick a piece and pick this part. Actually, we got the file from thingiverse.com. So, and then they also teach all these powered hand tools. So that's another class. So, please follow me into the assembly room. Earlier this morning, somebody came up to me and said they brought with them carbon fiber, 4 tows of carbon fiber. They're about this thick. And they said, can you help me sew this together? I need to sew the edges. And I thought, I don't think this is possible, but actually it was possible. So we sewed about 4 layers of carbon fiber fabric on this morning. It's a lightweight sewing machine. The sunglass holder you saw outside, 2 students made that last week, and they learned the sewing machine. Second day they made our sunglass holder. So there are several applications for the sewing machine, including inflatables that we're working on. Another machine that we have is the Next Engine Scanner. Have you guys seen the Next Engine Scanner? So the Next Engine Scanner, if you've heard about it, Jay Leno used it to scan his car. We are using it to scan the Sophia model there. So we have 3 students working on this. They've been working on this for 2 weeks straight. We received this model with no plans, no drawings, no 3D model whatsoever. We only had this. The Germans have for us. So we have a broken model. We're supposed to piece it together, reprint it, remake it, and give it back to whoever it is that wants it. So that's what we're doing. So students place this object in front of that scanner, and they've been scanning it religiously, day in and day out, every side. Typically what you do with this scanner is you put your object on this rotary bed, it's supposed to go 360, and then it gives you an STL output or a mesh file of your surface. You can take that, print it right away, and you're done. But with large objects like this, it's a lot more difficult. So we're doing it in pieces. We broke this apart. It used to be all one big piece. So we're doing that simultaneously. We're going to take it into SolidWorks. We're going to patch it up and then print it or mill it out on the ShopBot. We'll see what's faster. So that's what we're using that for. We also have the Xbox Connect. You can scan entire rooms per person, surfaces with that. We just got this in about a couple days ago. We don't have the software yet, but we've tried a trial version and it works beautifully. So if we had this 2 weeks ago, it would have been great. We would have done that in 1 second, just gone around and done it. But we just invested in that, so that's good. Moving on into our okay, so here we have a vinyl cutter. A vinyl cutter is essentially a gantry that moves in one axis, and you feed it any flexible material such as copper or even vinyl. If you feed it copper, this is a copper adhesive, you could make flexible circuits. So here I'm getting down to a trace of 0.6 mil, if you can see that, you can't see that. But it's actually a very labor-intensive process to weed out the parts that you don't want from the parts that you want. You have to use essentially 3 different transfer tapes to weed all of that out. I've made a lot of circuits this way. It's not the most robust, but so it'll work for the first 2 days, and then 3rd day it'll like sort of work, and then 4th day it's gone, but it still looks cool. So we actually, that CubeSat on in your comic at the very end, we ended up making that. We gave that to Charles Bolden, our NASA administrator, last month or so. We ended up making the circuits in that photo. Actually, that front panel that has all those LEDs, that is this board behind that panel. We even have the 3D printed panel in the other room that you saw. This fits into that. It has an LED on each pad. This was connected to an Arduino. So we have a bunch of Arduinos here. We connected that to an Arduino, which is a do-it-yourself, quick, for us non-EEs PCB kit. And then we connected that to an accelerometer and put that inside of a CubeSat. So depending on how you rotated that, the LED in that direction would light up. We did that in 2 days. We got a functioning circuit in a couple days. The printed structure we finished in 3 or so days. So we had a functioning CubeSat prototype in less than a week. So that is the vinyl cutter. We also have a desktop mill. Now, of all the machines in the shop here, I don't know if you guys saw the downstairs machine shop. They have all the $1 million 5-axis equipment, but so they're doing all the metal, you know, any material downstairs. Of all the machines in this shop, this is the only one that cuts aluminum. So we can cut 5051 or 5052 aluminum blocks. We can also make wax, 2D, 3D wax molds for injection molding, or if we're just going to do a hand cast silicone mold, for example. You can also make rigid circuits. So we have our 4 copper board, and we put that in there, and we can make our own circuit board. But again, for the actual CubeSat that we made, we took the copper adhesive. We actually, the 3D printer board, we have a perforated board. We just ended up cutting that as a last minute hack. Put that on here. Now we have a rigid circuit, and that's how we got that. Most users and students, after they're done making their circuit, come to this area, and they can, we give them everything, all the components they need, oscilloscope, soldering iron. Normally at NASA you have to take a specific soldering course to be able to solder. Actually here, so users and students can come in and they can just start soldering right after I give them a quick safety briefing session, so they can start working right away. And we have more components here. So, culmination of this tour, I'd like to say that I think the most important part of what we've established here is, first, we're creating a place where whoever works here at NASA can come and build something yourself. And that hasn't happened yet, at least here on site. There's no shop, no machine shop of all the machine shops that you can go into and make yourself, and build something yourself. So this is the first one. Second, downstairs we have 30+ years of machining experience. We have created a new synergism with the traditional manufacturing technologies and the advanced here. They're helping us, we're helping them. If you come here with and we don't have a capability, then we get the guys downstairs to come and help you guys as well. So it's this new, we're combining forces, essentially. So I think those are the greatest parts. And finally, I'd say the coolest part about it is we're spurring creativity in the NASA Ames workforce. We're hoping to change the way people start to approach the projects, whether it be design thinking or just conceptualizing. It's more of a quick, rapid prototyping shop for everyone here. And we can help you with your project, or you can come, train, and help yourselves with a project. So, thank you, and you guys can ask me any questions.
What do you say to them to make it stay so neat?
What do I say to them?
Yeah.
Actually, this is not neat right now.
No, it's really neat by comparison to other places.
I send really nasty emails.
Okay.
No, I'm actually always cleaning.
Like this, it says clean up your stuff.
Right, I'm cleaning after everyone. That's yeah.
You should make them do it.
I should. I will. So.
How do the students or the folks that want to, how do they sign up? Is it like
how do they sign up?
That you would have?
So the schedule's on the board outside. So there are 8 classes. We teach 4 classes in the mornings, 4 classes in the afternoons. If you wanted to, you could take all 8 classes in 1 week and be done. Yeah. So that's how so the way they're scheduled now, you have to come to the shop, sign up in person, but we're in the process of getting them all online and automated. So things run very slow here. And we have to get legal to approve these things, especially because we're going to make this public, at least all the documentation, so we need their approval before we could do that. So we're not going to wait for that. We're going to open up and have that work in the works simultaneously. So.
Do you know like the tolerances on your like the scanning? For example, if you scan it, are you within 3%, 5% of?
I haven't done enough scans on that machine to know, but I know the highest resolution is about 50,000 data points per square inch.
Okay.
Yeah, that's highest resolution. Yeah.
Yeah, the AFRL Directed Energies Director, their computer modeling, they're getting way up there. Like
yeah.
So and they'll do a lot of CAD work, and then they'll have it done through additive manufacturing, CAD, CAM, etc. And so,
yeah.
And they're getting really close to the dimensions, so when
right.
they're pulling it out of the virtual environment into the real environment.
Right. Okay. So here's one file of that piece right there. There are each of these is divided up into so many scans or faces. So there are about, I think, 36 scans that he did to be able to piece this together. So this normally, ideally, would have been placed on this bed and rotated, and you would have gotten that perfect scan. But because it's so large, we had to physically move it every time and do a single scan, and then we had to paste it together. So I'm not sure how close that is to the real thing. We haven't checked yet. So.
Okay.
But it's a really good question.
Yeah, it matters because if you're machining something and it's a replacement part without
yes.
waddles or puts the cube Saturn set into an off square position.
Yes. Yeah. Yeah. But everyone's excited. They're like, "How's your scan coming along? This is huge. If you can get it to come out as close as possible to the real thing, then that's pretty big for repair." So how many of you guys have been to Tech Shop? Yeah? It's pretty similar.
Yeah. This is like your private one.
Yes, but the difference I'd say is that we're hoping to solve problems here, specific problems, space problems. So there's myself, and there are 2 other people who are helping me as project accelerators. We go through every day. People come with their projects from various codes around the center, and they have various problems. So we sit with them, we consult with them, and we divide up, how do we conceptually approach this? What new machines, what workflow, in what order? What new way can we build this? So I think that's the difference between what we're doing and what Tech Shop's doing.
Is there any cost to use this program?
Right now, no. Right now, there's no cost. Eventually, there will be a cost, but I'm hoping that is a long time in the future. Because so in 1 month, we have 150 people using the shop already. I think that's a big success, so I'm hoping,
Any big problems solved so far?
Any big problems solved so far? Little problems.
Or optimized?
Little problems. No, not in the short time period that we've been open. But since it's summer, we have a lot of summer interns as well.
Oh, yeah.
So we're helping them. It's not just building, it's also CAD work, it's design. What kind of 3D modeling program do you use? So sometimes we'll have short workshops with them, tutorials, we'll help them out with that. But I think a lot of the time spent with me is kind of like, somebody comes up to me and is like, I have a .sbp file. How do I change that to be a blah 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 file to run on this machine? So then I'm like Googling for half a day to figure out, what plugin do I need to install to do this. So it's the little stuff, and that's what digital manufacturing is. It's how to solve from A to Z, and it's the lack of the similarness and representation amongst processes, right? I'm creating a 3D file as faces or as a solid model, but then I'm going to the 3D printer and it's printing it in layers. That's not how I thought about it in the first place. So we're trying to close the gap not only with the hardware but also software and how we represent things. So, yeah.
I saw the sign clearly. You can't use this unless you have a NASA badge. But
Yeah.
the folks at Singularity U that have access to the Center Kit?
That's a really good question. So,
because Made in Space came out of Sing U 2 years ago. This wasn't available, but holy cow, they would have liked to have had it.
yeah,
So-
Made in Space has been working here too on some of their stuff
Okay.
recently.
They don't have NASA. Do they have NASA credentials?
I believe they do.
Well,
I
I guess
believe now
they
they
do.
do.
Formal agreement.
Yes,
with
they do.
NASA,
Okay,
so-
all right.
I think with Marshall.
Would the Space Act agreement get you access here?
Oh yeah.
Oh, correct.
Oh yeah.
Or the Space Act agreement
That's
that
like a
covers-
couple
Any
little ways
kind of,
away.
so my
but-
first two questions to anyone is, are you over 18 and are you working on a NASA approved project? Could be a Space Act agreement, could be a grant, could be an internship through NASA, could be NASA related.
Okay.
And if you're working on furniture, then you're practicing one time. So,
Yeah, and I would say for some other examples, you guys just did the Google Plus Hangout
Yeah.
Make magazine
Oh, yeah.
last
Yes.
Friday.
and I was
so-
wearing the same thing. Darn, if I knew you would watch that, I would change my outfit.
Well, I don't know if they've watched. I'll try to remember to tweet a link to it in a little bit, but it's just on Mixed YouTube channel. And
Yeah.
it was really cool. We had all these different stations, and Sarah and Matt gave an intro, and then they worked through all the different stations of sample type things that had been done here or could be done here in this kind of environment. And Made in Space was here, and there were people doing synthetic biology stuff and the various CubeSats and all kinds of stuff.
Yeah.
So that really kind of gives you an overview, like here's somebody holding their thing, and that kind
Right.
of aligns with this kind of concept.
Right.
That's it. Then thank you so much.
Thank you for coming.
Yeah.
Yeah.